What up, y'all? Happy happy Tuesday. Not sure what day it is. Shut this for a sec. So the first part of today's class, we're gonna talk about our upcoming test and kind of look through some resources that I have for you all, as well as have a visitor. And then the second part, we're gonna finish lesson 8 material. So let me make sure that we're up and running on our live stream. Okay, here we go. So let me send that all to you and I'll also update it. So let me go gallery, I think it is. So today's live stream link. And then let me get that to you here. Copy and paste. It's good to see you all. I mean, it's good to see your presence. I wish I could see your bodies. Yo, what up, Sebastian? Thank you so much. One thing that I'm really curious about is what blocks. I don't have any insights onto what would block a student from showing themselves. I think there's a lot of good reasons why you might not want to show your face on Zoom. And then maybe you can't. I know some students don't have cameras, but I have a genuine interest and curiosity in learning what those barriers are, just so that I'm aware of them. A lot of my colleagues will say students don't want to show themselves, and I don't fully agree with that. I think our system is not really designed so that you have private space to study in, right? And a lot of you are at home watching Zoom in your public space. So there's people around you and there's noises and all that. And that's one thing that's been on my mind for a while. Like, what are some of the blocks that come up, just so I'm aware of them. So let me repeat this real quick. I'm going to put today's, Okay, I think I need to, I was going to put today's YouTube video online, so I might do that later. Let me just show what's on my mind for today, and we'll kind of talk through the beginning of class. We're going to take it a little slower today from the standpoint of not jumping right into math, but instead talk about structure. I also have an opportunity for many of you. I just texted those that I think it's most appropriate for, but there are some other folks that I think might be interested. Before we start that, let me just go into there we go. Okay, so today we are, let's see here. So we're on lesson 8. We're going to finish up the absolute value stuff. So hopefully we'll finish most of the lesson 8 handout, and then we'll move on to lesson 9. We are slated to have our second exam on this day, but and I want to treat this like a normal exam. Let me be really clear. I want to give you a chance to practice what it's like to take a college math exam. I'm not going to grade it like your other teachers would grade it. In fact, we're going to do multiple iterations of this, and you're going to get credit for making mistakes. But I think we're close enough to the end of the quarter that some of you are going to go on to take another math class. And I think it's worth talking about some of the structures to support performance on math exams. For those of you that I'm lucky enough to work with again in Math 48B, this is not going to be as big of a deal because we have literally till the end of June to get you some study skills. That was I set out a set of text earlier this morning about a problem solving team that I want to put together in this class. But for I know Andres and I believe Sean, you all are going to go to the Math 12, right?
Sí, señor.
Yes, sir.
Awesome. Yeah, so for you two, I do want to start talking about that class. I think is going to be pretty brutal from the standpoint of the pace of the class and also the way that he structures his tests. And so I want to start getting you all ready to be able to thrive in that. I believe you can survive, and not only survive, I think you can thrive. But That takes a little bit of what I would call like vaccination. We got to strategize how to do that. And so for everybody in this class, this second exam is going to be a mock exam, meaning to say that we're going to do kind of a practice scenario, a scrimmage, you could call it. And we're going to talk through it. We're going to work on, you all will be able to grade your own work, and you'll be able to tell me what grade you think you deserve. I'd like everybody in the class to get A's. But I also want to give you the opportunity to really build those skills so that when you go on to other classes, you have the capacity to really understand what that exam environment is all about, and then to not be chewed up by those in-class exams. And so we're going to start our class today kind of talking through that so that we can kind of prep. We have 7 days until that exam happens, and then we'll do some decompression after the fact, and et cetera. So that's one thing that's on my mind today. Let me be quite clear. If you all show up to this and engage in the way that you've been engaging, my intention is that you get an A. So let us separate the concept of grades on the exam from lessons that we can learn on the exam. Yeah. And then the other thing I was going to say is that at 10:30 today, we're going to have a special guest, a guy named Baba Kofi. He's a professor at Foothill that teaches computer science, and he's teaching a special CS 1A class. And so he's going to come at 10:30 and kind of present that class in case some of you are interested in taking computer science classes. And then around 11 today, we'll get started with lesson, the rest of lesson 8. And then I guess the last thing that I'll say out loud is that I'm looking to put together a problem-solving team. I've contacted most of you. Sebastian, I still have to send you an email. And I'd like to send Andres, if you're interested, I'd like to send you an email. There's no pressure on it, but some of the stuff that we might talk about, it might be interesting. Jasiri, are you here with me today? I'm not sure if Jasiri's in the room.
Yeah.
Hey, what up, Jasiri? I kind of want to send you that email too, or that text too. So you might, did I already send it to you, Jasiri?
I'm not sure because I haven't been checking my email.
Okay, I wanted to get your permission to do it because I think you are, I forget, is it business?
Yeah.
Yeah. Yeah, so at some point, I might send you that if it's okay, Jasiri. You don't have to answer that right now. We can connect one-on-one later today. But there's a part of my mind that feels pretty strongly that I'd like to give you the opportunity just to think about it. And the opportunity looks something like this. So the text that I've been sending out is maybe see if I can get to a good structure of this. So how to solve it. Basically, I'm inviting each of you, everybody in the class is invited, but this is really what I would call, this is not AYSO, this is CYSA. So if you ever played soccer, or another way to say this is like you're making it, this is a commitment, like it's not a light commitment. And if you're not super excited about doing math in your free time, you might think critically about this. The flip side, though, is that this problem-solving team that we're going to put together, I'm going to make a claim. Our work together in this team will set you up to solve any math problem that you'll see in any of your classes from now until the time you finish college. Now, given we're not going to be able to finish all of our explorations by the end of this quarter, my hope is that this team will outlast this Math 48A class so that we'll actually do it to the end of Math 48B. And the team would basically meet every Thursday starting at 8:45 a.m. until about 9:50 or 9:55. We would study a book that I call, that is called How to Solve It. I've kind of shown this before. So we would probably read 5 or 10 pages every week. You would do that on your own. We'd come in, we'd debrief from the 5 to 10 pages. We'd kind of do small group work. And then I would give you basically one problem that's kind of hard. And we would spend probably 30 minutes individually, like in small groups and small breakout rooms, trying to solve that problem. And then we would come back and I would actually show you some principles of how to make progress on those. And it's not really me that's showing it, it's actually you all. You'll kind of debrief and go from there. And my claim is over time, not only will we developing your ability to solve technical problems, but we will be building skills that could help you navigate a very punishing education system. I like to call math teachers dream crushers, because they take our dreams and they, in kind of like a molcajete, they like break it down into a nice like pieces, like guacamole kind of, except instead of aguacate, it's your dreams, right? So this is one way that we can really inoculate ourselves against that capacity that math teachers have. So I've sent out a text to all folks that I think would really get a lot out of that experience. Folks that I think are going to have to go on to many months or years of math study. If I haven't directly sent you a text yet, Sebastian, I know that I haven't sent you one. Jasiri, I really want to send you that text. We can check in later if you'll give me permission to do that. Art, I haven't sent you yet, but you and I talk pretty often, so Art, you'll be getting that as well. If for whatever reason I haven't sent you one and you will like it, so Andres, if that was something you're interested in, or Sonali, I think Sonali I might have needed to. I need to check that again. And Sophia, you can let me know in the chat, or you can text me at my Google Voice number. This is an open team, but it is a little bit of a commitment. It would be about 1 hour and 15 minutes a week, of actual in-class meeting time, and probably like another 30 to 40 minutes of reading. And that's the upfront cost. But here's a claim: if we do this work well, I have the sense that you all not only can pass all of your math classes the first time around, but you might even grow to get 4.0s in all of your classes eventually. That takes some time to get there, meaning that we will actually be setting you up with a foundation to thrive in any math class that you take. So those things won't be a barrier anymore. And so anyways, that's just something that is to be on the radar. Let me shut up for a minute and see if you have any questions before we launch into some exam conversations.
Yeah, Jeff, I think I'd be down for it.
Awesome. Okay, Andres, let me just mark that. Yeah, let me show you. I don't know if I'm not sure if I should show you this, but I kind of want to actually. So let me show you the way that I've been tracking this, just as a class. So what I did is I went into, so Andres, here you are. And then, ¿qué quiero decir? Verde. So over here are people that I think would really get a lot out of this. I think everybody in the class would actually get a lot out of it, but it's a non-trivial commitment, right? And for those of you that I want, for those of you that are going to go on, have already made that commitment in the choice of majors, I almost want to say that it's not a choice. So like Abiri, Jason, Yassine, Jaden, Sean, Jasmine, Jasiri, I kind of don't want to give you a choice, but I also want to, before I make that decision for you, I want you to have a chance to kind of talk through it. So what I do over here in this green is basically identify people that are going to take probably at least 3 or 4 more years of math based on their desired majors. And then over here in this column, I highlighted in green people that I've already texted. So I haven't texted Joel yet. I haven't texted Andres yet. Sonali, I suppose I should probably chat with Sonali individually. And so then when you all respond, what I'll probably do, so I don't know if I've gotten responses yet. Okay, so I think I got one response of somebody that was not able to make it. So what I'd probably do is, if you can't make it, I would just put an orange there. And there are ways, if you can't make our individual meetings, there are ways that we will record all of our work together. And so you can see me speak about some of the principles, and then you can also get the book yourself, and I will post all of our problem solving problems in a special place. And so you can actually kind of watch the pre-recorded parts of the lesson and then kind of read on your own. And I'm happy. So for the person that said that you're not able to make it, you and I can chat individually about ways that you can still get the value without having to show up synchronously. And so Andres, I will be sending that text out to you later today, hopefully. Our first meeting is actually this Thursday. Let me just kind of show this. We call this, I might call this the problem solving team. So let me go to my current schedule. I'm so sorry that it took me this long to put this together. It literally took me 6 weeks to get my head around what virtual learning meant. And so last week was really like the first time that I felt like I had the bandwidth to take on something new. Don't tell my wife, she's going to be really upset that I'm doing this, because she always says I'm way overcommitted, which is true. But so like we would actually meet this Thursday for the first time at 8:45 in this Zoom room. So just sign into the normal Zoom room, and I'll do my best to prepare some special support for our first meeting together. And then the last thing that I'll say is that this is going to be highly active. So I'm going to try to speak for no more than about 15 minutes a day, because problem solving is like athletics. It's so much better if you want to get in good shape to actually run around the track than it is to watch an Olympian run around the track, right? Okay, so I'll stop on that. If you're interested or you'd like a follow-up, and I haven't already contacted you, just please let me know. And then for the folks that are busy during that time, let's check in, let's do our best to check in individually, and we will find ways to support you in the learning, even though that happens asynchronously. I will say that part of what the structure that I'm trying to create is that we actually learn how to work in teams. So I will say that I plan to do this in 48B at the same time, Thursdays between 8:45. So you might now, if you're getting ready to make your schedule, you might block off 48B is going to be the exact same time as 48A, my 48B class. And you might just see if you can block off that little morning slot for yourself in spring quarter. If it's not possible, that's okay. Because part of what we're going to be doing is building community. So it's not only that we're learning how to solve problems, but we're also getting to know each other so that you all can take other math classes together. And that's the way that we work as a familia, right? And Andres, that's one of the reasons that I think this is really special, because Sean, I think, is going to be in that as well. And if we can get you and Sean to work together like every day, then when the two of you go into Math 12, you'll have extra support in that way, right? And I think that's really special. That's
a great idea.
Yeah, I mean, this is, sadly, this is the first year that I'm doing this systemically. So you all are kind of watching me struggle a little bit because I don't have all the systems set up, but better now than never, right?
Yeah.
Yeah, and I mean, the same thing is true. Like, we're going to get you, I want you to connect with our other Umoja family, and then also some people that aren't in Umoja, so that you all can actually build teams of people that sign up for the same math classes. And then you're not alone in those classes. We can talk later about whether or not you should tell the teacher that you have friends in the class. That's something that is a strategic decision.
Mm-hmm.
But there's actually research that proves that if you take math classes with other people who are serious students, that you're so much more likely to succeed in the class because you're not alone, even if the teacher is what I would call unfriendly. Okay, so I'm going to stop that. We have a visitor coming in about 10 minutes.
Is it Tracy?
No, this time it's a guy named Baba Kofi. He's a CS professor with the Umoja program, and he's also he's got a great story. Every time I talk with him, I learn something about myself, which is just so exciting. What I wanted to show you next was a project that I've been working on. So anyways, I'll stop there. Our first problem solving meeting is this team meeting is this coming Thursday at 8:45 a.m. we will be working on how to solve it. You don't have to have a copy of this book in order to start that meeting. My hope would be that we can get you a copy of this book between now and next week. If you think you can buy this on your own, we'll talk about you doing that. And if you can't buy it on your own, I have some ideas on how we can get you a copy. So we can chat about that on Thursday of this week. Okay, with that, let's go back to kind of the main dish. That was all dessert, right? For the main dish in this course, we're getting ready to have our first mock exam. And I call this a mock exam because it's going to be the exam process without the normal grading. So my intention for you all is if you engage in this exam and submit your work, I hope that my plan is that you get an A. So in other words, your performance is not graded in the way that my performance used to be graded, which is on whether or not you can get correct answers. Your performance will be, I will assess your work based on what you feel you're learning. And if you're serious about, if you take it seriously like you do yourselves, I guarantee we'll learn stuff together. And so what I wanted to say is that we have literally like about 1, 2, 3, 4, 5, 6, 7 days before that exam. The exam is going to be a kind of a subset of problems that review lesson material from 4 through 8. And what we're going to do, I haven't decided yet if we wanted to do, I kind of have a question about this, if we should do a mock in-class exam, or if you all want to do a take-home and then we grade it together. I'm open either way. There's a part of my brain that says kind of a mock in-class might be useful. There's some research studies in learning that say that if you practice the way that you play, that you're much more likely to play at a higher level. Or another way to say that is, let's think about this exam as practice for your future. I don't know how other math teachers are running their exams in Zoom world, but I've heard that they're doing like timed exams and you're not supposed to look anywhere. And like, does anybody have intuition on that? How people do?
It's stupid. The way they run it right now, it's kind of, I've never had tests the way they run it. It's kind of annoying.
How are they doing it?
Well, at least I'm in a business law class, so they have he'll have like 20 questions. You have 2 minutes to answer each question. It's almost based off memory, so they don't have. Yeah, that's the way he does it. It's a multiple choice, of course, because that's like the easiest way to do it online.
Yeah.
But they make the quiz based off their lectures, and
is it timed?
Yeah, it is timed.
Okay. Does anybody? Thank you so much for sharing that, Andres. Anybody else have a sense of how folks are doing exams in other classes? I have no. This is the first time I've ever taught like this.
I was gonna say my roommate. I think he has like this website called like Proctorio or something, where it has his camera on and it has to be facing him, and he's not allowed to like. Basically, the computer will decide whether or not he's cheating, and if it thinks he's cheating, then it'll just cut the exam off.
Okay, so first of all, I'm going to straight up say in my class, you can use any resources you want always. So and I guess the only cheating would be if your dad did the exam for you, or your mom or your friend or whatever. But the fact of the matter is this is about your learning. And so, and I really respect each of you as learners. And even if that happened, I would say that's my failure and not yours, because my incentives weren't aligned with your needs, right? But I will say that experience that Andres and Sebastian were saying, I've found as more of a dominant experience. So what I was thinking is we could actually, I could give you the list of maybe 6 to 8 questions on this day, and then, or I could give it you beforehand. I haven't figured that out yet. If you all want to do a mock exam that you actually, you have some time to work on them. And then I would grade it like I would grade a mock exam, and then I would actually post solutions, and then you could do the exam corrections, which is where the real learning happens. And then at some point we could debrief from that experience and talk about what we learned. And then we could do the same thing with the final exam, knowing that your grade is not dependent on whether or not you get right answers. Literally what we're doing is we're getting you ready for a scenario where you have a teacher that uses that practice, right?
Can I continue your metaphor of weightlifting?
Yeah.
I feel like we should be maxing out next week, right? Put on the weight, Jeff. Make it hard.
All right. Well, but the flip side, though, is that I refuse. There's something called psychological trauma that results from math instruction. And that's where things get scary to me, Sean, because there are people that when they see exams, their mind will shut down because of it. Does that make sense what I'm saying there?
I'm in that camp, but to what you said just moments ago about our continuing education in math will not be cushy, right? Let's make it just like it will next quarter for a harder teacher.
Then I would ask each of you to make. I'm happy to do that, but I want to make a deal with each of you, okay? And I can't make that deal without your consent.
That's to a certain extent, though, because there's some professors that are just like Jeff, and this is their first time doing it online, so they're also keeping leeway. It's going to be the same way next quarter. So, I mean, like what you said, Jeff, I agree that I mean, we should take it in class. And I mean, I've always been, for a lot of my accounting teachers, do it the way you do. We will take it in class, and then we have corrections after because you see what you did wrong and stuff. So to me, that's always made sense as a student, but I mean, everyone's different.
Yeah. So I think you and Sean are speaking the same language, actually. We can do both and rather than either or. And I don't want to say that just because two people have spoken that the whole class has spoken, because that's definitely not true. But the deal that I would want to make is that we look at this as an opportunity for learning rather than what I would call a formative assessment rather than a summative assessment. So the goal of this is not to give you a grade. The goal of it is to help become conscious of what testing strategies look like for you, what your testing strategies look like, what you struggle with, and then to start helping you build some longer term learning strategies that support that type of testing. And so if we can do that, to me, that's way more important than the performance on the first draft. And we'll kind of talk through that together. And Andres, that follows up because the structure of this thing, we can do corrections. You can make, like in my corrections process, I actually give you points if you make mistakes. so it's not, it's very different from most people's experience in math. And then we have like a whole process to analyze that. And then Sean, what I heard you say and what I might try is, I'll write the exam as if I was writing it for a quote unquote normal class. And then what we'll do is we'll just kind of, we'll launch it together. We'll actually kind of, you all will have a chance to work on it, but it's not an all or none, right? So if at the end of the time you don't finish, don't worry, you can finish later. If you make mistakes and you mess up, don't worry, that's not going to affect your grade negatively. In fact, my claim is the mistakes are the most valuable part of the exam, and we'll actually do debriefs for about a week, and then you'll have another week to clean it up and submit your work. And then if you're not happy with my claim is that I hope all of you, my intention is to get all of you A's on that. But if you feel that you could do some more learning, you could resubmit at any time. Does that sound okay? Okay, so what I'll do is I will prepare some materials for you for the next time we speak together. I got a lot to do for Thursday for this class. Oh my God, I think I just gave myself like 7 hours of work. The last thing I say before Baba Coffee is going to come in here is I have a website that I think is really kind of useful. It's this Conquering College website right here. That is now turned into the learning code. So some students and I are writing a blog to help folks navigate college. and that's called the Learning Code. But the Conquering College stuff was my early version of this. And the reason I wanted to call that out, I'll go ahead and drop this into the link. Let me see here. There are some really nice resources for thriving in math classes and specifically on math exams. So I like to say that the fast way I sell this is I want to help you get a 4.0 in your major and also in all of your college classes. I don't really care about 4.0s other than I want to help you pass any class that you want. And not only pass, I'd like to help you be strategic and thrive. And so these are all documents that I've written with that goal in mind. And if you look, do you see the titles of these? How to use suggested problems, how to prepare for a math exam, how to manage yourself before an exam, how to thrive on an in-class exam. Now, we're not going to cover all of this in one quarter. There's also this thing, how to take advantage of office hours. Andres and Sean, I kind of want to, at some point, I'd love to talk with you about this for not just Mark, but also for like the STEM Center and stuff as you go on to Math 12. I wanted to highlight these resources because as we continue on in this class, we might actually study some of these. And then also in 48B, for those of you that are going to hopefully work with me in 48B, we will definitely be studying more of this material as you get ready to launch into your 48C class. So if we can combine this strategic navigation with problem solving with the content knowledge that we're building, I think that will go a long way to supporting you in other classes. So we'll talk more about this on Thursday as well as next Tuesday. And then for the rest of the quarter, we'll do a little work at the beginning of every day to kind of start prepping ourselves as we launch out of the class. So I'm going to stop there. I'd like to welcome Baba Kofi. Hi. Hi, Kofi. So I'm gonna put you on mute real quick. Baba Kofi is a professor here at Foothill in computer science, and he's also associated with the Emoja program and does great work in our communities. Today, he has an announcement about, I think it's a CS1A class, right? As well as an event. So I'm going to pass the mic over to my distinguished colleague. Hopefully he can kind of give you a sense of what's on his mind today. Hi.
Thanks, Jeff. If you could allow me to share my screen, I appreciate that too.
I think you should have that. Yeah, there you go. Great.
Okay. All right. All right. Thanks again. I'm glad I could visit this course because I want people to know about my object-oriented programming course. It is going to be offered next quarter with priority registration for Umoja and Puente students. And the whole idea behind this course is for it to be an introductory course to programming. It's for people who are complete beginners and people who don't know the programming language Java and want to learn that. And the whole idea is to give people a taste of what computer science is. So it's not just for people who are going to become computer science or are computer science majors, but also for people who want to understand programming, even if they are going to use it in another field. The whole idea is to make you a person who knows how to code, and we use a popular programming language, which is Java. And what's very special about the course is that I have done a lot of things to it according to the learning practices of Umoja and Puente. So it's just like every other Umoja course. You know, we do porch talks. We talk about different people across history who are of Black and Brown heritage in the computer fields, and we cover everything we would normally cover in a CS1A course as well. In fact, we use a very innovative textbook where people get to explore programming in a graphical way at the beginning of the quarter. Typically, people start off programming with just text. I like people to start off programming with graphics. In fact, at the bottom right is some of the visual graphics we use in the course, where we program robots in a simulated city, going through intersections between buildings and picking up those yellow things and that kind of stuff, which is supposed to give you an idea of what you might write if you were programming a robot, just like the robots people are experimenting on today for food delivery, which is what's on the top right. And it's a course that is transferable to both the UCs and the CSU system. And it's pretty much like the course I took, because I myself was a Foothill student. I took a different programming language, but I took a similar course right here at Foothill, where I got my associate degree in computer science. So that's pretty much it about the course, but I really want people to chime in and ask questions about it. So I'll let people jump on the mic or in the chat if you have any questions about the course. We're still not sure when the course is going to meet. We're shooting for Tuesdays and Thursdays, 2 to 3:50. This is what we call a Z course. In other words, it's completely online, but we will meet twice a week for an hour, 50 minutes over Zoom. But people who miss a meeting or they just have a conflict, they can watch recordings of the class afterwards, is the way I'm doing it. On top of that, I also make sure that it accommodates people who work full time. So even though we meet twice a week, everything is due at the end of the week on just before midnight on Sunday. So if you only have the weekend to do the work, you can do that. This is a 4.5 unit course. There are no prerequisites, no hard prerequisites in the sense that you can't register without them. There's a couple math classes that we that are advised, but frankly, the way I teach the course, if you just know enough logic to drive from wherever you live to Foothill College campus, you really have enough logic already. I mean, we really start off programming robots in intersects, moving across cities. So if you know north, south, east, west, and true and false, that really you're fine. Yeah.
Now, I know what coding means, or I've heard the word coding, but what does it like? What's like? What do you do like when you learn to code? I don't know what people do. Is it like you learn how to like fix a computer, or is it like what is it?
Oh, good question. Well, so yeah, what you're learning to do is to be a programmer, not the person who builds the computer or puts it together or hooks it up to the internet. So those are different skills. What you're learning to do is to program the computer. In other words, tell the computer what to do. One way to put it is you are learning to write Java applications that you could just run on your desktop computer, right? And the way you do that is we have you install a free development tool called Eclipse, and it allows you to edit these text files. And in those text files, you write instructions for the computer, and then the Eclipse program automatically compiles it for you to an application code, and then when you run that code, you have a program running on your computer. So in the bottom right of the image I'm showing is a running Java program where you have a red robot going through those gray streets in between what are supposed to be green towers, putting down or picking up those yellow things and avoiding the black walls. And so that's a program that's running on your computer. This one was running on the Mac, but Java programs run also on all the other popular operating systems like Windows and Linux. So you would be writing the code or the instructions for telling the computer how your application should work and what should happen.
Got it. So what's Java?
And Java is just the language you write the code in. I mean, there has to be some sort of rule. I mean, you can't, unfortunately, write it in English or something like that, but you can write it in a language that people write that a program called a compiler understands, and it takes your Java code that you write and converts it into what your machine understands, and that's what actually runs on your computer. So it's a way of writing your program. And this course is actually object-oriented programming, where we organize everything into what we call classes. That the whole idea is to help you understand that kind of programming. There are other ways to program on a computer, but this is just one way. Java is one of the most popular ones. Over the last 10, 20 years, it's been the most popular. Another popular one is Python. That's neck and neck with it right now. But it's something that's worth putting on your resume if you are going to be a computer scientist or just someone who needs to know how to code and what coding means. So I have people who are high school students, who are dual enrollment students. And I also have people who are already working. I have people who like work for places like Twitter, but they're like managers, but they don't understand coding. Or they don't understand how to code in Java, so they take the course so they can understand that. So I teach people I've taught people 16 to 80 really. It just all kinds of different people because programming is becoming a big thing that a lot of people need to know, not just the computer scientists.
Got it. So like you could, like with that job, do you is it like you keep the computers running, or do you help help overall with computers, or do you fix
No.
certain
So
things?
well, yes and no. So there's all kinds of different things around computing. Some people build a computer, some people fix a computer, some people connect it to the internet, and some people program the applications. And this is just a course on programming the applications. People who put the hardware together, they would take a different course. They would probably take this course too.
Gotcha.
Good. I wanted to say I love these questions. Thank you so much for being a leader. One of the things that I was thinking, Baba Kofi, as you were speaking and Jaden was speaking, I'd love to meet with Jaden to talk through some of those, and then maybe if he takes your class, he can also meet with you in office hours. Do you plan to do that?
Yes, I do. I'm sorry, I have to turn off my other device because he's stealing my microphone. Yes, and I can even meet with him before that. That's totally fine. Uh, yeah.
Wow, that's awesome. Jaden, you and I can connect about that. I love your questions right now. You're driving deep in there. One question I had for you, Baba Kofi, is how often do you plan to teach this class? Is it once a year or every quarter?
Well, I teach it every quarter, but I teach it for Umoja and Puente every spring quarter. So this class is a special section in the sense that everyone who's in the Umoja learning community and the Puente learning community gets priority to register. So, this course is very popular and it fills up quick. But if you're in Umoja or Puente, you'll definitely be able to register as long as you do it before the deadline.
Yeah, and I guess one last question that comes to mind for me, maybe other folks have other questions as well. If you have special, I think you do, but just to say it out loud, special ways that you support our Umoja and Puente community and kind of help them, help all of your students, I imagine, but folks in that class thrive despite the fact that the class quarter goes fast, or if they fall behind, or if there's anything that you do to kind of support students' lives.
Well, there's some things I had already done before I made it an Umoja course, and there's some things I added in as an Umoja course. But frankly, once I taught it for Umoja the first time, I just expanded that to every time I teach it. What's the advantage is people get priority registration now. But one of the cool things is the porch talks. This is a Umoja practice. It's one thing that I've always done is I have people work in teams. So for the larger assignments, I have people work in teams doing what we call pair programming. That's where they work online, but they use special software that synchronizes their work over the internet. So it's like they're working on the same computer, and they take turns between who's doing the typing and who's doing what we call navigating, which is looking at the big picture, looking for bugs, reading instructions, that kind of thing. And you switch off every 20 minutes. So that way, there isn't this problem that you often have in classrooms where when people working on teams, someone's doing more of the work than the other. So it's an equal workload. And it's a much better community to work in when you work in teams that way. There are other exercises that you work on individually, but the larger labs are done with the team programming. And of course, I'm always available not only for my office hours, but I also make appointments for anyone who asks for one to meet with them on Zoom, where we can share screens and help them through any problems they may have. So it's just like any other Umoja course in those senses. Thank you for asking that. I forgot to talk about the team programming.
Hi, Baba. This is Sean. Nice to have you here. I just want to bait the witness. Can you describe to us what is an algorithm?
What is an algorithm? Well, it's
Yeah.
basically a sequence of steps that you are, at least in the context of computer programming, you're trying to get the program to do to get some task done. And it may involve steps that are in a loop or something like that. But the whole idea is, there's a sequence of steps to get something done, and you have to tell the program, the computer, exactly how to do those steps to get that thing done. So maybe you're telling people your program to figure out a way to get through a maze, for instance, right? Like in the example I have on the screen, this is a maze assignment where you program your robot to go from the top right corner entrance down to the bottom left, where there's an exit. You can't see the exit in the screen though. And you have to tell it, okay, what's the process? Do you check the right wall all the time or the left wall all the time? When do you put things down? It's kind of breadcrumbs, that kind of stuff. You got to tell the program how to do what you want it to do, and those sequence of steps, we call them algorithms.
Right
People
on.
use the word algorithms differently in what different fields. In math, where the word originated. It means something slightly different, but it is still a sequence of steps. It's actually comes from the last name of a Muslim mathematician. I've forgotten exactly how to pronounce his name, but that's where the word algorithm comes from. Actually, the Muslims were really, really big in mathematical knowledge in their universities. In fact, that's why we use the numerals we use, the Arabic numerals we use for math.
Right on. Sequence of steps. Got it.
Hmm.
Also, I'm interested in taking your course. I'm also very interested in getting to learn SQL. What other languages would I need to get my feet wet with besides Java before I can like start doing some stats with another language? Like, would I need to go on to C plus or something?
Well, there's a whole universe of languages out there, and a lot of them do similar things. So, in fact, one thing I do in the first week of the course is really talk about the whole computer science field and what are the different things you can do after that course. Um, and what we typically do in our computer science department is we teach 3 languages to students in the first year. Oh, you have a choice of one, right? You can take 3 courses in Java, and CS1A is the first one, or you can take 3 courses in Python or 3 courses in C++. They're all object-oriented programming languages, and just you can take a whole year of one, or you can mix it up. You can take 1 quarter of CS1A in Java, and then CS3B in Python, and CS2C in C++ if you want to. It just depends on what you're interested in. Reason why you would learn SQL though is to program databases, and that would be in a much later course that we teach on database management.
Would I be able
Yeah.
to get there with a very strong foundation in Java then? Or like they all do
Sure.
the same thing, that's what I'm
Any
hearing,
of
but they're
you
all
wouldn't need to
applicable to
know
different
Java to
platforms.
learn to learn SQL. SQL is just for databases.
Nah.
But people typically take the database course after they take the first year of either Java, C++, or Python. Either one, any of them would be fine. Certain schools prefer Java, so the CS1A course is probably the most popular one, which is why we're making it a Moja course, because it's more applicable to um, uh, more institutions out there, like in the CSU and the UC system. Welcome. I wanted to not take up too much of Jeff's time. I want to also talk about a different event. I think that was the last of the questions, right?
I had one last question about signing
Okay.
up. So it sounds like Umoja and Puente students that are in Umoja and Puente classes get priority registration. Is that right?
That's right. So basically, when registration opens up, they'll have priority. So when other people sign up and they sign up, they'll be first. And in other words, other people end up on the waiting list unless the whole class is full of Umoja and Puente people, and then the Umoja and Puente people start ending up on the waiting
And
list.
one way maybe that we can go forward, I have some folks in this class, Curtis and Jaden, and also Delol and Lamin. There's some folks that I think would really like, this would be a wonderful opportunity. I'm not sure how that works out with their academic plan. And so I was thinking maybe to get Tracy to come in and have individual meetings with that team, so that we can make sure that if they were to take it next quarter, it would fit into their academic plan as designed.
So as I understand, that's how Umoja works. They would just talk with their counselor
Awesome.
before they sign up for spring, about their
Yeah.
plan for spring. This is a Umoja course, but it's not an Umoja course that is required by everyone. So the entire cohort doesn't have to take it. It's optional. So you would talk with Tracy first, or whoever your Moser counselor is.
Awesome, thank you. So you maybe wanted to transition to the other thing. That was just on my mind so that we could get it
Oh,
out.
no problem. That was great. So the other thing I want to talk about is something happening next week. One thing I'm doing in my class is, like a lot of professors, I'm having people come and speak as part of Black History Month. And what's going on Monday in my current CS1A class is I'm having people and a speaker come to talk about high-tech worker cooperatives. Cooperatives are where everyone, or at least the majority of people um, uh, who own the company are the people who work in the company. So, in fact, the one that the speaker Jacoponte works for, which is called Palante, everyone who works there owns an equal share of the company. And that's a way for people to create a space where they can have a good living and a good work environment because they democratically control the corporation that they work for. It's something that people should have it on their list as a place they could work for or create. You might, get together with your college friends and start your own worker cooperative, right? So that's what this event's all about. It's going to be Monday during my CS1A class at 2 p.m. 2 to 3 p.m. And what's interesting about this event, on top of the fact that they're talking about um, high-tech worker cooperatives, is we're also going to utilize a 3D meeting environment called Mozilla Hubs. But most people will experience it through Zoom, and the way you sign up for that is on the screen, but I also put a link into the chat so people can sign up that way for that event. Again, that's on Monday, 2 to 3 p.m. Okay, and I'll also post the flyers. Any questions about the event?
Sounds entrepreneurial.
Yes, it is, but it's entrepreneurial in the sense that it's all supposed to be a good place to work, right? Where you really control your hours. It's not like the CEO is forcing you to do 8 hours a week. If you and your fellow coworkers decide to do 8 hours a week collectively, well, that was your all's choice, but probably you'll choose less. And typically in worker cooperatives, the sharing of the money or the profits are much more equal. Usually there's only a 5 times differential between the lowest and the highest paid person, if there is any differential at all. So for those co-ops where some people do get paid more, they never get paid more than 5 times the person who gets the lowest pay, which is not the case for your big tech companies. I think, well, the richest people in the world are founders of big tech companies, like folks like Zuckerberg and the Amazon founder and so on, and they're getting like 400 times the people at the bottom. So yeah, it's a much more um, equitable situation and a much better place to work because you choose how you work. You and your fellow coworkers democratically choose the rules.
Let's give Baba Kofi a big thank you. I don't know if you all want to, I don't know how we do that. Maybe, can we do reactions? What do we do? Like,
Reactions are good.
yeah, the little
Love it.
hand clap or.
Thank you.
Thank you so much, Baba Kofi. I hope that
you.
we'll have some folks in this class that will be seeing you next quarter.
Oh, I'm
And
tired.
hopefully I see people on Monday as well. And I'll
Oh,
just bow
yes.
out and wish
Yep.
everyone peace and love.
Awesome. If I'm teaching during that time, otherwise I'd be there.
But not this course.
Not this. I don't think this course. It's good seeing you. Thank you so much for all your hard work. You deserve a raise.
Well, thank you. And we know you deserve a raise.
I'd love to give. You don't have to pay me anything more. Just let me have 10 students per class, you know?
Okay, we gotta spread you around though. That's not fair. All right, guys.
Hey,
Bye bye.
much love, Kofi. Bye. Okay. So let me stop that. And then what we're going to do now is we're going to transition into the rest of
No.
lesson 8. I'd love to give you a chance to maybe a few minutes to kind of get your head straight. So it's 11:01 right now. I'd love to start again at 11:10. And specifically, we're going to be working on lesson 8 material, the stuff that we didn't finish from last time. So specifically, if we go to our course homepage, and then we go down to lesson 8, which is all about absolute values. We're going to download a handout. And I forget at the moment, maybe I need to, as we're doing this, I think we got to like page, does anybody remember where we stopped on this one? Probably like page 4. So we'll start again on page 5, and then we'll hope to finish as much of this as we can today. With some homework, I put some homework in here as a gift to you for later. All right, so we'll start again at 11:10. In the meantime, if you want to get your materials out, do that. I will be here in this room. I'm not leaving. I'm going to get the solutions from last week up. I thought I already did that, but apparently not. So at 11:10, we'll get started. Go ahead and get your mind right. If you want to ask questions or raise concerns or comments, feel free to do so. What'd you call it again, Sean, from last time?
But when the stage manager releases you, the whole cast goes like, thank you 5 or thank you 10. In this
Thank you,
case,
10.
thank you 8. So the stage manager is managing like these big ego equity, actors. And if they don't get their fucking donut coffee break, there's hell to pay. There's extra overtime, and then the theater company just goes bankrupt. So that's their job.
I see. Thank you. Thank you, 8. How hard to carry around that ego, right? Sounds like a headache.
Heavy.
No, thank you. Art, are you still in the room?
Yeah, yeah. What's up?
I was hoping, so the folks that are going to be in our problem solving team, I will likely be suggesting as 48A tutors or Math 105 tutors. And I just was hoping that we could capture this because I think I don't really know, is the first quarter that you do the pass the torch tutoring, is that paid? Can you kind of just remind me what the structures are of that first quarter?
Last I remember, it was the first quarter, it's unpaid, and because you're still learning how to do it, and then the second quarter, but you get something else in return. I don't remember exactly what it is, but the second quarter of it, then it's paid.
And what's it paid at? Is it $15 an hour or $10 an hour?
Well, I think it's around 15 and up, I believe.
$15 an hour or higher.
Yeah.
And then do you have to sign up for, I forget who has to sign up. Is it the tutor that has to sign up or the tutee? Or I don't remember what they call, was it mentee and mentor? What's the word that they use?
I think they both have to sign up. It's a tutee and tutor, I guess. Yeah.
So the person that is going to tutor signs up for a tutoring class, and the person that is going to get tutored signs up for a learning class, right?
I think so. You sign up for Pass the Torch in both aspects. The person that's tutoring also has to take a supplemental tutoring course, I believe.
Awesome. With Nicole Gray.
Yes.
She's my teaching mentor. So for those like Jasmine, you and I can talk about that because you have a lot going on right now, but like I would love to get you to be a tutor in your next quarter. Jasiri, I'm not sure, you and I want to connect with, but Jaden and Lamine, Andres, Sean, I'd love you to have that chance. So in addition to the problem solving team, for those of you that are going to go on in math, I might want to get you paid to do math. And a really good way to do that is to get you to be a pass the torch tutor. One of the best ways to learn math is to teach math. And so that job would basically entail that 2 hours a week, you would be helping students who are in like Math 48A or Math 48 105, or I'm not sure what other classes we offered that you all could tutor, but you'd be basically helping them get through their work. And one of the reasons that the How to Solve It book is so useful is it will, even if you don't know how to solve one of their problems, you'll have a mechanism that you know how to approach the problem, even if you don't know the specific content. And Art has a lot more information about that pass the torch tutoring if you wanted to know it. And then there's some people in here that are actually, that have tutors from Pass the Torch.
Right on.
Yeah, it's pretty cool. Those who can do, those who teach do better. And then the other thing I wanted to say is I could have made a lot more money had I gone and worked at Google or Facebook. One, I don't believe that those companies do all the good that they think they do. And then two, I really didn't like supporting Mark Zuckerberg's bottom line because he'd be getting my intellectual work to make him richer. Right now, do you know who benefits from my intellectual work? You do. So I don't get paid as much as I could have, but I get to pour my work into you and to Foothill community. And to me, that's so much better than making Mark Zuckerberg a few extra million or $1 billion. And so I love what Baba was saying.
I think Google literally got rid of their do no evil.
They had
part of their company policy. They literally got rid of it.
They literally had to, because they do no evil was nice as long as it kicked back money to the shareholders, right?
Just
kind of
funny
crazy
that businesses use their mission statement as a complete ploy and diversion from what's actually going on behind the curtain anyway.
Yep. Which is like, yeah. And the reason that that's useful is that you all are going to go on to be the leaders of society, and money is very, very strong. I made a self-sacrificing play in my job at Foothill, but that's because nobody can pay for my time with my family. And one of the things that I ask from Foothill is that I'm able to have time with my kids every day and my wife. And that's something that Google would have taken away from me, even though that they would have paid me a lot more. And I would encourage, my hope for each of you is that you find a job that makes you smile, even if, and that supports your bills, even if it's not as sexy as it could be, right? Okay, so what I wanted to do is kind of launch into lesson 8. We were talking about the absolute value, and we had these two different realizations. We had one of them that, does anybody remember what this was called? I must see her here with us today. She had Sierra last week, just hooked this up. She was so amazing. Maybe when she gets back, we'll have her work on this. But anybody remember what this was called? It's written here. Jasir, are you here? Or Giovanni? I think Giovanni might not have a microphone. Or Sophia?
I'm here.
I just got back. What's up?
What up, Sophia? Do you remember what this, Jasiri, what's up? Do you remember what this representation was called, where we had the little bracket and then the 3 different pieces? So this is on page, I'm not sure. Page 3, I think. Page 3 of lesson 8. So specifically, we had this, what we saw was we had these 2 equivalent representations of the absolute value function. Jasiri, you remember what they were called? Starts with peace, ends with.
I totally forgot.
Oh, that's all good. Vincent, you remember?
Yeah, piecewise.
Piecewise. Jasiri, what was it called again?
Piecewise.
You got it. Sophia, what was this called?
Piecewise.
Piecewise. All right. So what we're going to do now is see if we can come up with a conjecture. The word conjecture means a mathematical guess. This is one of the reasons that I think it's so stupid that we mark you wrong for guesses, because professional mathematician makes guesses all the time. Like my whole job as a mathematician is to make guesses and then either substantiate my guess with a proof or come up with a counterexample to show that my guess was not right. So what I'd love to do is actually come up with, let's make a guess. And this is where, is Jason in the house?
Yeah.
What up, Jason? Do you remember last week when I was doing all that notation, how painful it was? Because it seemed like I was going so slow.
Yeah.
Okay, today this is going to kick in. Do you remember what we said about the different parts of the anatomy here? Let's see if we can remember. So what did we call the little straight line on this side?
Didn't we just like call it the left and right absolute value bar?
Yeah, you got it. Damn, Jason. Okay, so then we'll call this the left absolute vodka bar, absolute value bar, sorry. Went back to my college days right there. And then what about this one? It's anybody else.
It's the right absolute value.
Nicely done, Andres. All right, and then do you remember what we called the thing on the inside?
The argument?
Yeah, nicely done. Was that Sonali?
Yeah.
Sonali, any chance that I have you join that problem-solving group?
I'll talk to you after class.
Okay.
I like half. Yeah.
Okay, yeah, it's not a no. This reminds me of what is it, Dumb and Dumber? So you're saying there's a chance.
It's like it's a 50-50. I'll talk to you why later.
All right. All right. So we've got that expression inside, or the argument of the absolute value. And then the claim that I want to make is, what did we say was true? So let's think about this not in terms of X, but instead in terms of the argument inside. And this is why I spent so much time doing this. So let's make a conjecture. And I want to highlight in pink everywhere that argument shows up. So let's do it over here. The absolute value of X is equal to X if X is greater than 0, 0 if X is equal to 0, or negative X if X is less than 0. But instead of using the letter X, let me ask you to use the word argument. So Sebastian, are you with me?
Yes.
Okay, so let's do the first one. F of X is equal to the absolute value of the argument means that it's actually just equal to the positive value of the argument if the argument is
Greater than 0.
Okay, so let's go ahead and translate that over here. Say that same sentence again.
G of X is equal to the what was the number in the argument? If the argument is greater than 0.
Yeah, there you go. I did a very rookie move, which is I didn't give myself enough space. So what we're going to do, this is a guess. We're actually not sure if this is true. And this is one of the most exhilarating parts of math, that we can write false stuff and still get value out of that right. So what did you say? We said that in the piecewise definition, say that one more time, Sebastian.
G of X is equal to the argument to absolute value of 2x plus 2 if X is greater than 0.
Oh, be careful though. What was the condition on this? Is it just X, or is it the thing inside?
Oh, the argument. If the
Yeah,
argument,
so what is the argument there?
2x plus 2.
Yeah. And this is where it's nice to be able to abstract and actually, and this is why I was doing this last time, Jason, because if we haven't taken a really deep look at the math, we might confuse ourselves between the symbols and the structure. And the structure is what we're doing here, right? Okay, and then let me just go ahead and confirm that this is a conjecture, and I'll just put an upside question mark over that because I'm not sure if this is true. All right, so we got the first condition. We said that the first condition, we drop the absolute value bars and just take whatever was on the inside, as long as whatever's on the inside is greater than 0. All right, what about the second condition? Chelsea, are you with us? Chelsea's what I call a survivor. She's such a strong woman. Every one of you is really strong, but Chelsea makes me smile when I think about her strength. Curtis, are you here? Or Katrina?
Yes, I'm here.
Could you guess what the second one is?
Well, it's gonna be the X. Well, it's gonna be, wouldn't it be the 0?
0.
Or would it be the value?
Yeah, because literally we're saying that the value of this has nothing to do with the argument. We're literally saying it's 0. But when is it 0? When would that be 0?
If the argument equals 0.
Wow, look at you. Are you a math major?
Yes.
All of you are mathematicians, regardless of your majors, right? Okay, so you're telling me that that would be 0 if the thing on the inside is 0, right?
Yes.
Okay, nicely done. And Yasmin, are you here with us with Aries as well? Or also Lamin? Or
What's
Mark?
up?
Hey, what up, Lamin? Could you guess what the third one is on this?
Negative
Yeah, nice. Keep going. Keep going.
Negative x.
I agree with you, but use the word argument. So I agree with you if the argument, if the thing in pink is x, then we take the negative of the thing in pink, right? Or in other
Mhm.
words, say whatever the argument is, we hit it with a
Wait,
negative. In this case, what's the argument?
x.
Is it?
Oh, the argument, the 2x plus 2.
Yep. And what are we going to do to that 2x plus 2?
We're gonna if negative.
We're going to hit it with, keep going.
Negative x.
Yeah. So, but remember, we're thinking about this as negative whatever's on the inside. So in this case, is x on the inside?
Oh, yes.
Well, yeah, I agree with you that there does show up, but is that the only thing that is on the inside?
No,
What else is on the inside?
the 2x plus 2.
You got it. And so what are we going to do in this third situation? We're going to hit whatever's on the inside with a
Negative.
Okay, so in this case, what would we do?
So put negative.
Yep. And when is that true?
Wait, why is that true?
Not why, but when, because we're not sure why. We have to answer after we confirm whether or not our guesses are on. But like, use the word argument. What does it mean, argument again, Lemmy? You're doing such a good job right now, brother.
I really don't.
What does argument
X,
mean again?
The expression of inside. Something.
Yes. The stuff. This is where abuelita stuff comes in, right? Inside absolute value symbols. Okay, so use that word. For the third case, what do? We hit the
argument -2.
When do we do that?
If the inside, wait, I don't know.
Yeah, you got it. If the inside is
Argument. Expression of
yeah, if the
inside.
expression is what? What value of the expression would we have there?
Argument.
Yeah,
wait,
but
what
what's
do you mean?
when do we hit it with a negative? What must be true about that argument?
Shit.
When do absolute values turn the
right
thing inside from negative to positive? Like what's true? What would I have to put into an absolute value in order to make it the opposite of itself?
What do you have to do if you put in what?
So like when do absolute values translate negatives into positives? What type of number do I have to put in?
0, 1, I think.
So let's try it. Absolute value of 0 is
0.
0. Does that change?
No.
Okay, what about absolute value of 1? You're doing such a good, you're making a conjecture right now, Lemmy. This is a beautiful conjecture. And then now what we're doing is we're refining your conjecture. Absolute value of 1 is
0, 1.
1. Does the sign change on 1?
Not really.
No. So it's 0 and 1 don't change. Could you give me a number that does change when you hit it with the absolute value?
I don't know, 4.
Let's try it. Absolute value of 4?
-4.
Oh, there you go. Okay, so you're telling me that we change the sign when what? When the input is
when the input is X.
Negative. That's what you were just saying, right?
Yeah, if a negative number.
Yeah. So you're telling me that when
Number.
whatever's on the inside turns negative. Great job, by the way. You just
Yeah,
did the
negative
work of
number
a
again.
professional mathematician, Lemon. You made a conjecture and then you tested your conjecture. Beautiful. Absolutely beautiful. I helped you a little bit. Eventually, you're going to get there on your own. I can guarantee you. So proud of that work, my friend. Did you
I
feel the
kinda forgot.
pressure?
Yeah, I kind of forgot the steps.
It's all good. Forgetting is necessary to learn how to remember. Okay, so let me ask you this. And this is ustedes, not just Lamin. You, ustedes, all of you. Let's see if we can refine this a little bit. 2x plus 2 equal to 0. So let's go ahead and graph. Let's do a quick graph to kind of figure this out. All right. What's the slope of this one? And I almost want to go to Andres just to make sure that he's got this, because a few weeks ago we were talking about this. What's the slope on this line?
The 2.
2. And if we were to think about it as rise over run, could you write it in that form?
2/1.
Yep. And then how about the y-intercept? And for this one, is my friend Sierra still here?
Yes.
Sierra, what's the y-intercept of this one?
2.
2, you got it. And let's write that as a point. So the y-intercept, the x value is always, do you remember?
I'm sorry, what's the question?
What the x value is for the y-intercept.
1.
Try again. Close.
2.
What is the y-intercept?
Is it 2/1?
Oh, I agree with you that the slope is 2/1 for sure. But what does the y-intercept represent? You're doing such a good job right now, by the way. I love to see you struggling. You know what we call that? We call that learning.
It's where we are at on the y-intercept.
The y-intercept is where the line touches the
X-intercept.
Ooh, I agree with you that the x-intercept is where it touches the x-axis. So the x-intercept is where the line touches the x-axis. The y-intercept is where the line touches the
Point of intersection.
Yep. With what? With which axis?
The x-axis.
Try again.
Y-axis.
Yeah, there you go.
Oh.
Okay, so say that again, full sentence.
The point of intersection between the y and x-axis.
The y-axis and the line.
Oh, the y-axis and the line. Okay.
Okay. So do you remember what the x value is along the y-axis?
2, you said?
Well, let's see. If x is 2, everywhere along that vertical line, x would be 2. Is that the same thing as the y-axis?
No.
Okay. What about if x is 1? Everywhere along a vertical line right there, x is 1. Could you guess what this one is?
0.
0. So you're telling me that that vertical line has the equation x equals 0. So let's go ahead and write this. This is the vertical, line, which is called the y-axis. Beautiful. So you're telling me that every point on the y-axis has what x value there, Sierra?
0.
0. Y-intercept, what's the y-intercept?
2.
Yeah, the y value is 2. This is the place.
Oh, I don't know. I keep getting confused.
You're doing really a good job. I'm loving it. Remember, the y-intercept is the place where the line touches the
X-axis.
Try again.
Y-intercept.
Y-intercept is the y-axis.
Okay.
Say that one more time.
Y-intercept is the y-axis.
You got it. Y-intercept is where it touches the y-axis. What do we know about all points along the y-axis? What the x value is?
0.
0. So if I were thinking about the y-intercept, could you guess what x value that has?
0.
0. Nicely done. So the B is the y coordinate, the 0 is the x coordinate. So let's find that. 0, 1, 2. So that point right there, what's it called? It's called the
Y-intercept.
y-intercept. You got it. Okay, let's use this little 2/1 to graph. So maybe I need to be a little bit careful here. We'll call this -1, -2, -3. Sophia, Sophia, I've already worked with. Yasmin or Curtis, are you here with us?
Yeah, I'm here.
What up, Curtis? If we were to use the slope, what could we do with slope here? If I wanted to get the next point, 2/1, so what would I do?
You would go 2 to the right.
Yeah, so let's think about it. Slope is what we called rise over.
Oh, yeah. Right over around. So it would be 2 up and then 1 to the right.
Look at you, baller.
My bad.
No, don't you? Hey, when we make mistakes, our brain gets bigger, especially when we correct them, right?
Yeah.
So I want you to be really proud of what you just did. You're learning math. Every time you mess up, you learn. That's beautiful, my friend.
It's funny because I said it in my mind too, and then I still did the opposite.
Yeah, dude, it's hard to talk in public, right? I always do that, man. I like mess up. I mean, you're seeing me like 15 years into my career as a public speaker, right? So it's not really fair, but I know what you're feeling right there. All right, what if I wanted to go the other way?
And it would be 2 down and then 1 to the left.
Baller. And then here's our line, right? Okay, so let's go ahead and find where is the output equal to 0. Or another way to say this is, let's see, Jaden, you here?
Yeah.
Okay, so if we called the y-axis, we said that all x values along the y-axis were
0.
0. Could you guess what we say about the x-axis? What's the height of all y values along the x-axis?
0.
0. In other words, the equation for a horizontal line along the x-axis, could you guess what that equation is? What are all y values along the x-axis?
Y equals.
What's the height of everything along the x-axis?
So if x is 0, y is, y is like, 5, like 10.
Let's try 5. So if y was 5, we'd be at height 5, right?
Right.
So all points along that horizontal line have height 5.
Okay.
Is that the same thing as the x-axis?
No.
Okay, try again.
So I would say 6.
Okay, well, let's try 6. So 6 would be 1 up. So all points along the horizontal line 1 higher than 5 would be 6. Does that get us closer to the y-axis or farther, or the x-axis, or farther away from it?
Farther away from it.
Okay, so try again. So it's not 6, it's not 5. Is it? You think it's 4?
Yes.
Okay. So here's a claim. That line right there is y equal 4. This line is y equal 5. This line is y equal 6. What do you notice when I set y equal to a constant? What type of line is that?
It is a
horizontal or vertical?
Horizontal line.
Okay, so you're telling me that y equals to a constant is a horizontal line.
Yes.
And then the value of the constant determines the height, right?
Mm-hmm.
Okay. Well, which horizontal line are we looking for if we're studying the x-axis?
The X.
Yeah, you're right. You got it. This is called the horizontal line through the origin. What's the height of that horizontal line? If it goes through the origin, is it at 4 above 5, 6? What's the height of that horizontal line in the center there?
The horizontal line is 6. But we don't have 6. We have 5.
Let's see. Ryan or Sophia, you're doing really well here, Jaden. I love it. Or Jasiri, could you guess what the height along this horizontal line is?
Zero.
0.
Yeah.
So y equals 0 is the height of that line. Jaden, what are they saying there?
They're saying that y and x equals 0.
Yeah, x equals 0 along this vertical line, and then y equals 0 along this horizontal line, right?
Right.
So if I want to know where 2x plus 2 equals 0, so here my output is 0. So in other words, this equation is asking me, where does the line touch the
Oh, it's at 0.
Yeah. Well, is it at 0? What's the x value where the line touches the x-axis? Where's the x value where this line goes through 0?
Oh, I don't see where it goes at 0. -1.
Yeah, -1. So you're telling me that the solution to this graphically, we see x equal -1 implies 2x plus 2 equals 0. In other words, this is where the line touches y equals 0 as an output. That's basically what we're saying. When x equals -1, this line touches the x-axis. Let's go ahead and confirm that same thing. Instead of graphically, we'll confirm it algebraically. So let's do an algebraic argument. And this is where you all are going to take over and just kind of stun me, even though you stun me every moment that I see you. I wish we were in person. I would feel like I'd be a lot more effective. All right. Any suggestions if we wanted to solve that algebraically, what we would do to get the x by itself?
Subtract 2.
Damn, Jaden. I want to sing a song from the 90s. Boy, you know, nah, nah, nah. All right. What's the next one? And why did you choose to subtract there?
Because there was a +2 and it didn't have an x. So, and then if you put it to the other side, it works better.
Yeah, some people call that canceling out or getting rid of, right?
You want to get the variable alone.
Yeah, okay, so nicely done, Andre. So how would we get the x by itself now?
Divided by 2.
Yep. If I divide the left-hand side by 2, what do y'all tell me?
You gotta do it to the right-hand side.
Yeah, and this is where my students are cooler than I am, right? I mean, you all are always cooler than I am. 2 divided by 2?
1.
Okay, you tell me that thing goes to 1. 1 times x is just x. And then Lamin, or Jason, let's do Lamin first, and then I'm going to hit up Jason. Lamin, -2 divided by 2?
Wait, what?
-2 divided by 2?
-1.
Baller. Do you notice something?
X is equals to -1.
What do you notice about the two methods?
They're the same.
They're the same. Okay, so the claim that we are trying to figure out here is when we wrote this conjecture, is this true? Well, what did we say? We just said that the absolute value of 2x plus 2 is equal to 0 if 2x plus 2 is equal to 0, if the thing on the inside is 0. When is the thing on the inside equal to 0? What did we figure out? When is that thing on the inside, the argument, equal to 0? What x value does that hold for?
-1.
X equal -1. Okay, so let's go ahead and do that. Let's rewrite this sucker.
I'm sorry,
Let's
I
do
was in
2x.
meeting.
Yeah, that's fine with me. Someday, I'm not going to suck at teaching. Someday. Someday I'm going to get you all hundreds of thousands of dollars. That's when you really know that I'm good at my job, right?
That would be nice.
Yeah, I'd like to cut that check right now. I'd give all of you $100,000 and then buy you an entire office in your home. I'd do it at this moment, like get that money to you at this moment. Okay, what did we say? When is this true? When is 2x plus 2 equal to 0? When x is equal to
-1.
-1. So now I have a condition. When x is equal to -1, we're going to say that this absolute value is 0. Right? So now it's no longer in terms of the argument. Now it's back in terms of x. So let me ask you this. When is 2x plus 1 greater than 0? And let's look at the line. Remember, this line is 2x plus 1, right? So let me go ahead and highlight that in orange to represent that that happens at the orange point. When is the line bigger than 0? What's another way to say when is the line bigger than 0? When is the output of the line above 0? Well, remember, output y or is output x?
It's the y.
It's the y. So if I want to know when is the output bigger than 0, well, what would that mean on the graph?
It would have to be when x is bigger than -1.
Damn. So yeah, you're telling me that this happens, that is equivalent to saying when x is bigger than -1, right? Okay, can somebody tell me the punchlines here? Are you there?
Yeah.
Okay, I think you were doing really good earlier. How do you feel about it?
Good, I guess.
Okay, I think you were rocking it, Sierra. If we went to a club, I'd be like, I know that girl. I know her. You should let me in because you were rocking it, right? You're like, whoa, teachers go to clubs? That's weird. When I was younger, I did, yes, but not anymore. I'm an old man. Okay, could you guess if we say, if this thing is above, so we say that the output is bigger than 0 when the line is above the
x-axis.
when would the output be below 0? What's that equivalent to in the graphical method?
When it's negative.
Yeah, or in other words, instead of being above the x-axis, it would be
Below.
below. You got it. Well, when is it below? Let's go ahead and do that in purple. What x values make this thing below the x-axis?
When the number is negative.
Yeah, specifically what, so think about this. X, remember x goes this way, right? So we
Yeah.
said that the line is above the x-axis when x is greater than -1. the line touches the x-axis when x is equal to -1. When is the line below the x-axis?
When it's below zero.
Yeah, when the output is below 0, but what input corresponds to output below 0? Look at the kind of the thing here. Remember, the input is along the x-axis. What do you know about the value of x right there?
It's -1.
So if I wanted to go this way, if I wanted to go down, what values of x allow me to go down?
Like -2, -3.
In other words, anything below.
-1.
You got it. So our claim was we can now look at this particular structure. And then once we do that, Art, are you with me? Actually, this is a question to the whole class. Anybody know how to do desmos.com where you have intervals for x? So let's do this. Let's go ahead and write the absolute value of 2x plus 2, and we'll write that in orange. And then I don't know how to, do you know how to, Art, do you know how to like do intervals on Desmos?
I've done it before, but I have to like recapture it. Let me take a look real quick.
Okay, so here, this thing right there that we see, that's the graph of our absolute value function, right? So let's go ahead and put this as 20. Or better, Art, what would be even better than doing individual intervals is if you could see how we figure out the piecewise function. So I actually don't know the answer of that. How to do piecewise functions in Desmos. You remember I said fight Google? We were talking about how we like to put Google on a hot seat. Almost 100% of my searches are in DuckDuckGo. I still use Google for email because it's hard to take the needle out of the veins, but this is one of my little resistance. Okay, so let's see. Piecewise functions.
If you click that link right below it, it'll actually open a Desmos with that as an example, and you can kind of work off that, I think.
Cool, that's kind of fun. So let's see. We said, what was the condition that we used? Let's go ahead and write this. Piecewise. Why it won't let me do both at the same time? Maybe I'm like, oh, there it is. Okay, so let's put this over here. And then what we'll do over here. So what were the conditions that we had? We said one, when x was greater than -1, we said that the output was going to be what? So the claim is that this is going to be our condition, and then this will be the actual value of x.
Oh, x will be x. So
Uh,
it'll be
yeah,
2x.
2x plus 2, right?
Yeah.
So this would be 2x plus 2. All right. What about when, what about in the middle one? So let's do the next one. So it looks like the way that this works is we use commas. So first we do is the condition, which is the input values. Then we put the output associated with that condition. So the next one, we're going to do another condition. What's the condition on the second one? What's the value of x here?
-1.
Yeah, nicely done. So here we'll say x equal -1. And then let's talk about the output. What's the value of this function when x is -1?
0.
0. Nicely done. And then the last one, we're going to put comma. So now we have two things. We need the final condition. This is what Sierra hooked up. Sierra, what was that final condition? Curtis, you could take this one away too.
X is less than -1.
Okay, x less than -1. Kind of fun right now. The condition is 0. So do you see that? When it's 0, we get the horizontal line. You see that? I'm not sure. Somebody's at my door right now. I'm going to let them wait. I hope it's not my suegra. All right. What's the output value when x is less than -1? What's this output value on that particular part of the interval? You see it? -2x plus 2. Okay, so that's what we call our piecewise definition of our function. That was our guess. Let's take a look at the other one. If we drop 2x plus 2, and let's put this one in a different color. What do you notice about the two functions?
They're exactly the same.
Yeah. And we actually so we did the mathematical analysis to confirm our conjecture, and then now we're using a calculator to further confirm our conjecture. And in fact, we could, if we wanted to, this is a question for you. Maybe we as a group can do this. How to dynamically evaluate functions in Desmos. So talking about coding, this is kind of writing code. It would be really, really nice if we could say, like, let f of x, oh, that looks like it, right? So if I say f of x equals this, and then I evaluate f of 3. So let's check this out. So let's say that g of x, or let's look at our work here. So here, g of x is going to be this function, which is the absolute value, and then h of x is going to be our piecewise function. So let's call this thing h of x. And then strictly speaking, I would say that what we're about to do is code. So we're going to call the absolute value function g of x. And then we'll call this thing h of x. Okay. And let's see if we can, let's see if we can add a table. So this one's going to be fun. Let's call this g of x, and we'll call this h of x. I don't know if it's going to work. Anybody, any guesses? Oh, shit. You see it? We just wrote code, y'all. It's not super sexy code. I don't think we get paid $100,000 for this, but do you see it?
That's
so
crazy.
It's pretty crazy, right? Let's do the g of x in green, and we'll do the h of x in red. This is why I think that you should be allowed to use this in all of your classes, because it's free. It's better than the TI calculators, and you can do crazier stuff on it, you know? What are you noticing about our conjecture and the absolute value function? Did we do a good job on our conjecture, or is our conjecture false so far?
True so far, because everything's coming out to the same.
Yeah, and in fact, the nice thing here is we can actually fill out this entire table, right? And this is why I say, no, this is not cheating. Knowing how to use a computer is called learning how to get paid a lot of money for your brain, right? So this is where I just fundamentally disagree with the experiences that I had in most of my math classes, which is you had to do everything by hand. It's a good idea to learn the principles behind it, but once you know the principles, use your brain, aka use your computer. I'm guessing 4, 4, 6, 6, 8, 8. And then 14 would probably be the last one, right? And then later in this class, we're going to see a principle called translations. And that principle says that if I add 1 to x, I shift it over to the left. So we'll talk more about that later in the class. Oh, sugar. Sugar, I get so high. So high. Be like, don't ever sing to us again. Call my lawyer, Anderson. Okay. So what did we notice about, oh, sorry, you all can't see that. What did we notice about our absolute value conjecture in terms of piecewise functions? That every absolute value function we can write using 3 conditions. And then what we can do is a little bit of algebraic work on the conditions to get them into a form of just x on the left-hand side. And that gives us an equivalent mechanism to actually draw our absolute value functions out, right? I don't know about you, Art, but for me, I never saw this work throughout my entire undergraduate and graduate career. Like I never had, I did 9 years of my PhD, 9 years from the time that I started my undergraduate, 10 years really, the time that I ended my PhD, and I never actually saw this. This is the first time that I've ever done this in this class. Pretty amazing, right?
That's pretty cool.
Have you ever seen this way of doing this work?
No, I think I've seen that when you put it up into Desmos and stuff and splitting it up and doing the piecewise function, but not in my 48A class. That's definitely.
Yeah, well, so I'm learning along with all of you. That's the point. And also, I agree with Art. You all are getting your 3 steps ahead of your teacher, 4 steps ahead of the class. All right. So the next thing I wanted to do and we'll kind of end here. This will be the last problem that we do as a team. Is I wanted to think about a similar problem, which is to try to solve this problem, the 4 minus 2x, absolute value of 2x plus 2. And then on the right-hand side, we're going to have something that's a lot more interesting, which is 1/2 times x. So this is not a constant anymore. It's an actual function. God, I feel drunk without the fun. Let's do a little bit better. Okay. So let's think about this in terms of using a graphing calculator. So we'll go desmos.com. All right. So I need your help for a moment. What did we call the stuff? Let's do red, orange, and green. What did we call this portion of the equation in green versus the portion of the equation in orange? Sophia. Or Katrina. Or Jasiri.
Isn't it the right, like the left-hand side and then the right-hand side?
Awesome. So which one's which?
Green is left-hand side, which would be the LHS.
Awesome.
And then the orange would be the right-hand side, which is the RHS.
Okay, so you're telling me that this one is the green. And then you're telling me that this one is the orange. Any statement on which of those is easier to graph, which will take less brain power to graph?
Wouldn't it be the half?
Yeah,
the
tell
right
me
side?
about that.
Well, Wouldn't that be already the slope because we already know what it is, but we wouldn't know what the actual y-intercept is?
Yeah, so let's develop that out. So remember we said that y was equal to mx plus b, had slope m and y-intercept b. So this is the slope and the y-intercept. So that was called the point slope, or excuse me, the slope intercept form.
Wouldn't the y-intercept just be 0 if there isn't one listed?
Yeah, that's right. So you're telling me if I set 1/2 x, this is equivalent to saying 1/2 x plus 0, which would imply m is equal to 1/2 and b is equal to 0. So I almost want to go back to Sierra if she'd let me. I'm not sure if she's here. Sierra, you here? The only reason I want to do this is because it's a review from last time, and remembering takes time, right? We can ask other folks though. If we look at the y-intercept as a point, what is the x and y coordinate? What is the x coordinate for everything along the vertical line? What is x equal to?
0.
0. So everywhere we're on that vertical line is 0. And then the b value is the y coordinate. In this case, what's the b value?
0 as well.
Yeah, so we got lucky in this situation. Okay, so where x is 0, we know that y is 0. And then what do we do with the slope information? I almost want to go to Chelsea. If she's Chelsea, you with us? Or Marco? Marco or Chelsea?
Yes.
Okay, what do we do once we know the slope is 1/2?
You try to, can you go up 1 and then 2 to the right?
Very nicely done, which means if I go from 0 to 1, I'm going to go, or excuse me, 0 to 2, right? Because I go 2 to the right, 1 up. So my guess is that that should be a 1, right? Okay, let's try again. Let's go, say that one more time, Marco.
1 up, 2 to the right.
Okay, so I go 1, 2, another 1 up. Anybody see a pattern? Skip 1, 2, skip 1,
3.
3. Okay. And then lines go both directions. So not only do I go 1 up, 2 to the right, but I could also go what?
You can go backwards.
Yeah, 1 down, 2 to the left. So that would be -1, -2, -3. Like a good mathematician, I always have a ruler in my little utility belt.
I have a question.
Yeah, shoot from the hip.
Why does it say 4/5 right there?
Oh, you'll see that that was your old teacher being a little bit crafty. You'll see that that's a beautiful question. And in fact, we might actually, now that we did that, I'm kind of ready to use a calculator. So let's do the same thing that we just did earlier. So we'll go ahead and define g of x to be the left-hand side, which we said was 4 minus absolute value of 2x plus 2. And then we'll say that h of x is equal to 1 divided by 2 times x. And then what we'll do, what did we say? Orange and, so let's see, this was going to be green and this one was going to be orange. It's kind of nice that we can do that. I kind of want to make it thicker than a Snicker here. I forget how to do that at the moment. Anybody remember? So let's do plus a table. And then here we'll call the input x, and we'll call this output g of x, and we'll call the next output h of x. And then of course I should probably do the same color. So G will call green and H will call orange. And then here, where do we start our table?
-6.
Yeah, so -6, we'll push enter like one of our friends, -5. We can basically go almost all the way, except for here, 4 divided by 5. We're not sure why our teacher did that. Although, do you see a hint right there? Here, I'll give you a hint. Yeah, I'll stop there. We'll go down to the next one. 1, 2, 3, 3, 4, 5, and 6. All right, so now we've got all the table values. So this is -2.5, -2, -1.5, -0.5, 0.5. What was this one? Oh, 0.4, right? 0.4, 0.5, 1.5, 2.5. And then over here, it looks like we've got -6, -4, -2, 0, 2, 4, 2, -10. Okay, so one of those we've already graphed. The other one we can graph ourselves. And I do actually believe that even though we've done it on a calculator, it's still worth doing for ourselves. I might start with the vertex, which is at -1, and it goes up to 4. And then here I go over 1, I go down to 2. It looks like the slope of that portion of the line is going to be -2. Which kind of makes sense because there's a -2 right in the middle there, right? And then this one is going to go down by 2s. And in fact, right there is going to be the solution. So now, Curtis, I want to ask you, 1 is 0. There we go. Curtis, why did I include that little 4/5?
Is it because you wanted to? I'm just gonna shoot out a guess. To intersect the lines together.
Yeah, nicely done, man. I love that guess.
Oh, I got it for sure.
Yeah. In other words, what are you telling me? Where do solutions happen to equations?
At point of intersections.
Very nicely done, Andres. Solutions happen at point of intersections. Where are the 2 point of intersections here? Ruin that paper. So,
Are you asking me or just anyone?
sure, Andres, you could take that one. I was asking, it was just an open statement, but you can take it.
Oh, at our first one is we're at 4/5 and 0.4.
Yeah, I like to label from left to right.
Oh,
only
okay.
because- yeah.
Okay. Yeah, then your first point is at let's see it from here. What is that? -4, I think. -4, -2, yeah.
Awesome. So you're telling me right here, this is going to be 0.1, right? Because that's that one. And then 0.2, you said is going to be 4/5 in the input.
Yeah.
And then 0.4 in the output. And you're right, Curtis. I was specifically trying to identify that there are a few different ways to find those points of intersection. One of them is to actually look at the graph, but then the other one is to find the input values where the left and the right side have the same outputs, right? In Desmos, this is super easy because literally all I have to do is just hit See it? 4/5 is the same thing as 0.8, -4, and now all of a sudden I have the entire graph that I need in order to make the conclusion of where the two things are equal. Okay, so what does this mean about our solutions? Where are the two solutions? Remember, solutions are x values that make the two outputs equal. So if I'm looking for solutions to this equation, what are the x values that make the green touch the orange?
-4
Yep. And
4/5.
Yep. And guess what? We just use a graphical technique to solve an algebraic equation. All right. So now that we have those, we put those up here, and we'll finish today with an algebra technique. All right, and this is where I want to go back to all this hard work that we did to start the class. All right, so let's do this. So we're going to start, let's use an algebra technique. So this one we actually just finished. Sorry, page 11 on this sheet. So remember, if we have the absolute value by itself, if there's nothing else outside the absolute value, we can get rid of the absolute value bars by setting the inside equal to a positive or a negative, right? Okay, claim. Can we do that in this case? Can we drop the absolute value in this equation by just setting the inside to be a positive or a negative? Or another way to ask that question is the absolute value in this equation isolated? Is it by itself?
I think we should remove the 4 and our -1 coefficient before we try to drop the bars.
Okay, so specifically, how would you do that? If I wanted to get the +4 over to the other side, how would I do that?
Subtract 4 from both sides.
Awesome. So you're telling me drop a 4 over there and drop a 4 over here.
All right, and then we're going to multiply both sides by a -1.
You're a little fast for old Anderson. I'm trying to catch up here. So you're telling me this is 1/2 x minus 4. And then you said if I multiply this entire thing by -1, anything I do to the left-hand side, I should also do to the right-hand side, right? So let's see. Negative times a negative
comes out positive.
Positive. So now I've got 2x plus 2 on the left-hand side. And then here, it looks like I'm going to do this thing called distributivity, right? So this is going to be -1/2 x. Minus times a minus becomes a...
Things happen. Positive.
Okay. So now what we're going to ask ourselves, and we'll finish here, how do I get rid of the absolute values? What did I say? Was the 2 ways to get rid of the absolute value signs? If the thing on the inside is positive, I literally just leave it alone. And, so I have 2 options, right?
Right.
Option 1, if the thing on the inside is positive, what happens when I drop the absolute values?
Stays the same.
Stays the same. So the first option, I guess we would call it option 2 if we wanted to think about the dots, but in this case, we're literally just trying to identify the 2 different cases. So in the first case, in order to drop the absolute value, I just leave the thing on the inside alone. What's the second case? And I almost want to go back to Lamine. What's that second case, Lamine?
2x plus 2.
Yeah, but instead of this one, we left positive, but in the second case, we're going to turn it
Negative.
negative. Look at you, brother. So 2x plus 2. And then, of course, on the other side, we're just going to leave this as it was. Any suggestions on which of those we attack first?
Mm-hmm.
Okay, we want to get x by itself. Anybody see something you could do there?
Yeah, you subtract 2 to each side.
Nicely done. So 2 minus 2 is,
Wait, so can you pick both? like,
0.
can you pick either option?
we and not only do you have to, we're gonna pick both options, actually. Uh, 4 minus 2 is positive 2. And then this one's a little bit interesting. So here I've got negative 1/2 x. Kind of two ways to do this. One way would be to bring the 1/2 over. Does anybody get a headache when you're working with fractions?
Yes, sir.
Like an anxiety.
Yeah.
What would I do? Yes, Sebastian, what would I do to annihilate the fraction on the right-hand side? What could I multiply the entire right-hand side by to get rid of that fraction?
You can multiply it by 2.
Yeah, and to be honest with you, I might multiply by negative 2.
Oh yeah, negative 2.
But let's just do 2 for now, because I like, that was your idea, right?
Yes.
Okay, so on the right-hand side, I'm going to multiply the entire right-hand side by 2. If I multiply the right-hand side by 2, what do y'all tell me? Anything I do to the right, I must also do to the
Left.
left. So this would be 2 times 2x. What's 2 times 2x?
4x.
4x.
That's why option 2 is kind of nice because it.
Yeah, we're going to get to option 2. I promise. I promise. Okay, 2 times negative 1/2. Well, what's 2 times 50 cent? Don't say G unit.
$1.
Damn, I was about to say that.
Yeah, 2 times 1/2 would be 1, and I just have a negative. 2 times 2 is
4.
4. Okay, now what could I do?
Divide by 4. Or you can either add x.
Yeah, let's do that. Okay, so I have 4x and I have an additional 1x. How many total x's do I have?
5x.
Here I have 5x. On this side, these two things go away. That goes to 0. And then I have 4. What's the last step here?
Divide 5.
Divide 5.
Anybody see something that pops?
Yes, sir.
Okay, so that was option 1. And then what's option 2? And we'll stop there for the day. Let's finish option 2, and then we're gonna call it a day. We'll say we worked hard enough for the day. And you all can finish the rest of this. Now that you have this, I think the rest of this is all yours. So we'll say that this is what we call homework. And you can rewatch this video, right? I'll go ahead. I'll make sure to post this on our class website if you need it. And the homework is nice because it kind of tests you on your ability to remember. So one thing that I think is really great is that you all seem to be following along, but have you ever gone home and then you're like, I understood everything in class, but now I forget? That's where,
Yes.
yeah, that's so important for the learning process. Forgetting is so important for learning how to remember. And that's equivalent to right now you have a spotter that's helping you do their bench press. When you go home, there's no spotter. And so that exercise is so important. The nice thing is it's all on video. Let's do option 2 real quick and then we'll stop.
Can I ask a question?
Yeah.
When you put the negative in front of the option 2, why was that? I don't know if I got that.
Why did we do that?
Yeah, in front of the 2x plus 2.
Because the idea is when we get rid of the absolute value signs, there's really 2 ways to do that, unless you're in the middle, right? But like,
Oh, okay.
one of the ways is to take whatever's on the inside or the argument and just leave it by itself, right? In other words, take the positive version. What's the other way to do it?
To do the negative to see if
Negative.
it's
Yeah, and when we're working with this, what we really want to do is get rid of the absolute value bars because those are really a headache, right? So we get the absolute value by itself, everything else on the other side, and then we want to get rid of those. And what do we do to get rid of them? Well, one option is to leave the inside positive. What's the other option?
to add the negative to it. I was just confused because I saw us take away the negative at the top before you wrote out the options. And I was like, why'd he put it back in? But then I forgot about the intervals of how we have to do it to solve it to make sure.
Yeah, this thing we were trying to get the absolute value thing by itself. And then this one, we're trying to get rid of the absolute value bars. So different operations, although we needed to do the same step.
Yeah, that's just why I got confused, but I get it now.
All right, so what could we do here? Suggestions on how to solve this one? I'll make this fast for us because I want to respect your time. So first thing I can do is distribute it this inside. And then maybe I drop the 2 on the other side, right? -1/2 x plus 6. And then this one I'm going to do a little bit different. This one I'm going to actually do with fractions. So I'll go ahead and say that this is +1/2 x. And then I'll add 1/2 x over here. And then this is where I like to do a side note for that calculation. So -2x plus 1/2 x is the same thing as saying -4 divided by 2x plus 1 divided by 2x, which is the same thing as saying -4x plus 1x divided by 2, which is -3/2. And of course I have an x there. So on the right-hand side, I have something that looks like 3/2x. On the left-hand side, I have something that looks like 6. How do I get rid of a 3/2? What would I do to get rid of that? Well, anytime I want to get rid of a fraction, I can multiply by the reciprocal. If I multiply by the reciprocal on the left-hand side, I can also multiply by the reciprocal on the right-hand side. These two reciprocals, quote unquote, cancel out and equal 1. So now I've got x equal to 12 divided by 3, which is 4. Anybody see something nice about x equal 4?
Open back the other one.
And of course, I think, what did I do there? Oh, what's nice about this is I caught my own error. Anybody see what this is?
Negative.
Negative, which means this should be 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 negative. All right, let's end there. So the challenge for you all is to, for homework, finish pages 12 and 13. 13 has 3 of those examples. And then hopefully sometime later this week or next week, we'll start grading your submissions on Canvas, which is literally just to check that you've done them. So for the rest of the quarter, I'm hoping that you all would be able to submit. If you're a little bit behind, don't worry. We'll kind of talk through that as the quarter goes on. It's taken me literally 6 weeks to figure out how to teach a class virtually. And I'm still struggling.
Thanks, Jeff.
Beautiful work, y'all. For those of you that are interested in doing that problem solving team, we'll start on Thursday. I'll have content that I developed specifically for our team.
Yes. Thank you, Jeff.
You said 8:45 on Thursday, right?
8:45, yeah, in the same room. So just sign in at 8:45 in the same space we normally converge at, which is where we're in right now.
I was going to ask Jeff, do we need to bring anything other than the book?
Yeah, you don't even need the book for this quarter. For this meeting, hopefully we'll have the book ready for next meeting. Just bring yourselves and kind of a desire to try something new. I will prepare kind of a, what do you call it? A scavenger hunt of ideas that will be helpful for us. The first item on the scavenger hunt is going to be get the book in your hands by next Thursday. So if you already have it, bring it with you. If you were really excited about life and math, you could read through the first pages together, but that's stuff that we're going to be off-putting for next week.
Okay.
Appreciate it, Jeff. Thank you.
Yeah, much love, y'all.
Thank you.
Thank
Si
you,
se
Jeff.
puede. Si se puede.
See you later.
All right, see you later.
Thank you, Jeff.
Yep.
Thank you.
Jeff,
Yeah.
I was the one that had messaged you about that. I have class at that same time,
Yes.
and you were saying that you would have a way to kind of go back and watch the videos, so get the experience of it.
Yes.
Do you know by chance how that would work, or would it just kind of be a link like how the YouTube one is?
Yeah, so I think I haven't figured that out exactly, Katrina, and I'd love your help on that. One thing that we could do is, are you free after class every day?
Yes. So my
we-
last class is this class.
Say that one more time.
My last class is this math class.
Oh, awesome. So one of the ideas, I actually will soon, because the longer I teach, the more I want that book to be part of every class that I teach.
Mhm.
And so soon I'll probably have like a specific, what I call how to solve it page. I don't know if I'm going to be ready for that this quarter. So what I might do actually is at the bottom of this, our regular math 48A section,
Mhm.
I might call how to solve it teamwork or something like that. And then I'll put the worksheets for every day plus the lesson videos, just like I do up here. It's just for that particular meeting. And I can try to put dates associated with that, so you can actually see the date that we meet.
Okay, perfect.
And then the two of us can be in contact to make sure that you have all the resources. And I have a feeling, Katrina, that you seem like you're good at, you seem like you take your learning really seriously.
Yeah, I try to.
I
try to stay
get
on
that.
top of it.
Yeah. And so I have a feeling that you might be able to actually do, if you're serious about that and we get you connected. The one downside, Katrina, would be part of the work is supposed to be team building, and there's some special things that happen when we suffer as a team. Like, so the problems are going to be relatively hard. The nice thing is if this is all quote unquote extra credit, so it's not like your grade is affected when we struggle, right?
Yeah.
So one thing that I might say is if we can get you to a space, I'm hoping that I'll be lucky enough to work with you in 48B.
Yes, I was already looking at the you said it was going to be the same times and everything. I was actually looking at classes before ours started to see how to get my schedule ready for spring, since it's next week that they actually open up too.
Yeah, right. And so what I was thinking is if we could get you that slot open in spring, then you could just start attending at that point. Now, obviously, make your course decisions that fit best with your schedule, right?
Mhm.
So if it's the case that the best course for you to take is from 8 to 10 on Tuesdays and Thursdays, then just take that and we can continue in an asynchronous format.
Okay.
But the other side of that coin is that I might be lucky enough to work with you for 6 months, right?
Yes.
But then after we stop working together, I'm not gonna go on and teach 48C. I have no plans to do that for next year. And then the first class that I would teach that you might actually take would be 1C. And so you're gonna have like 48C, 1A, 1B. And I don't even teach 1C routinely. I teach it whenever I get assigned to teach it, basically.
Okay.
And so part of the problem solving group is not only to learn how to solve problems, but also to build lasting relationships with people in this class that you can learn to trust. And what's really nice about that is if you have like 2 or 3 friends that you feel really close with, you can then like go on into the next class with those people, and then you're not alone, right?
Yeah.
And in fact, one of the things that I'm going to work with in the problem solving group is you all will be given assignments to go meet tutors in the STEM center that you get to know. And so there's really like 3 things that are happening. Number 1, we're learning how to solve problems. Number 2, you're building relationships with each other. And number 3, you're getting integrated with our help systems. So in addition to the learning the STEM center, I would be recommending you to be a pass the torch tutor, which you can make $15. You don't have to do that. It's just, I want to give you that chance if you want to, right?
Yeah, of course.
And I think one thing that I think it's the case that pass the torch, Art, can you confirm, does pass the torch go all the way through 1A?
1A. I'm not sure about that actually.
I think it's the case that you can sign up to pass the torch through 1A. And I think if we do that, Katrina, you're going to be, not only will you be one and done, meaning that you take the class once and you finish it that quarter. I have a feeling that by the time you get to 1A, you're going to know how to get A's in your math classes.
Okay.
Everybody. Yeah, and you know who, it doesn't really matter if you get an A. It's just, isn't it nice to have the choice?
Yeah, for sure.
Yeah, and so that's kind of the goal there. And so I would say, Katrina, like, you got to make the decision that's right for you. But the flip side is if it's the case that you can swing a schedule where you in spring quarter where you're free for that time, my hope is that we can as a team really leverage that interactive environment to make lasting relationships that far exceed our time together, right?
Correct. Yeah. Okay.
It actually goes to 1B. So,
Oh,
Pass the torch goes to 1D.
Yeah.
That's new.
Wow. Okay. Yeah, no, because I know I have to go all the way. I think my last math class is linear algebra. Because I do.
Oh, I hope I get to teach that class.
Yeah, because I have to do all the way up to 1D and then do 2A and then 2B, according to my plans thing.
Yeah, I'd love you to connect with Art offline. Not that I would love to be for that, but he's taken my 1C class, he's taken my engineering 11 class, and he's currently in my 2B class. And I always like to say that my students know more about me than I do. And he can talk. I mean, I'm gonna try to make you laugh right now. Art can talk shit behind my back, right? Where she can't say straight to my face. And so I would love you to connect with him and just, I'm always looking for students to teach. And so you can kind of ask them, I hope to earn your trust enough that you could take my 2B class when you get there.
Yeah, no, of course.
That's my baby. Not my real baby, my mathematical baby.
Your mathematical baby.
Yeah, I put a lot of love into that class.
All right. Yeah. Okay. Sounds good. Well, then I'll just wait for some information about a link or something like that if I see it on the website for the one before class, the meeting that you're doing.
And let's keep in contact with me about that. Like, don't please do feel free to like ask me that question when you arrive at class. And then if you see that I haven't updated, like I do really appreciate the extra help to remember all that stuff.
Okay, perfect. And I know I could like sometimes I don't have class those days. Like once in a while, like I know this upcoming this Thursday and next Thursday, we don't have class, but it's because we have a class presentation that we're doing. So we're using it as a meeting time, like a workshop with the rest of our group members. So I know like in case if that it ends early, I could hop in if that's okay. I don't know.
Always, yes. It's always okay. Yes.
Okay.
For sure.
All right, sounds good. So in case it ever ends early, because sometimes we do, I could go ahead and hop in for the time that I have before our class starts.
Awesome.
Okay, cool. Oh, and one last question. I was looking at the book and I know there's like 2 different books. I don't know which one it is specifically that you want.
Well, tell me
I was
about
looking online.
Can you show me that? Can you share your screen? I don't know if I think I allow screen sharing, right?
Let me see. Yeah, I can share my screen. Let me look it up again.
Mr. or Jeff.
Yeah.
So before she shares her screen, I'm having a hard time finishing all this work that you gave me. All these packets I have to print out. So can I do it on like a separate sheet of paper or like for the work or something?
Yeah, most definitely. You're saying, so let me ask you this. Are you saying that you're having a hard time doing it in the space that I provided to you?
Wait, what space? Sorry. Is it like the...
I guess when you're saying, Jaden, do you have a few minutes? Let's connect. Let me wrap this loop up with Katrina, and then the 2 of us can chat. Does that sound okay for you?
All right. Yeah, I have a meeting at 1. So
yeah. Well, yeah. We hopefully we'll finish well before that.
I'm gonna share my screen really quickly. There's 3 different covers and I don't know. I know one says like how to solve it, a aspect, and another one says a new aspect.
That one right
Oh,
there.
well, if they're both here.
I don't know.
I don't
I've
know if
never
it's a
actually
specific
seen
cover.
used on eBay. Oh, those are just used versions. I've never actually seen that pink cover, to be honest with you.
Do you have the white one or the cubic one?
I have
This
both
one or
of I have both of those. So I have both this white one and I have the cubic one.
Okay. Are they
I've
2
ne-
different ones or does it matter which one we get?
No, they should be the same. I've never compared the two of them, but like the content of them is identical. I can say that. I'm sure some of the pages are different. I've never seen the little pink one. That's something that I've never seen, to be honest with you.
Okay, perfect. Just so I know to kind of get a hold of which book, because I saw them and I was like, I don't know exactly which one it is.
Generally, I like the idea of buying cheap. I just don't know why. Yeah, I can't answer that question right now. You've just taught me something new, which is there's a third cover.
Yeah. Okay, sounds good then. Alrighty then. Thank you, Jeff.
Yeah, you got it, Katrina.
All right, so yeah, so I'm just, I don't know. You said what space were you talking about?
So tell me, you gave me some really good feedback just now, and I want to make sure that I address the feedback in the way that you've given it.
So, like, I'm just having a hard time because most of my classes are online and finishing up the worksheets. I haven't been really as active in finishing them, and I'm just like I'm having a hard time doing that, and it's so can I use binder paper or like scratch paper as a separate sheet of paper so that
Yes,
okay,
for sure.
all right, and I'll get those in and I'll make sure I can turn them in. And so you want me to take a picture of it? I'll take a picture of it and I'll send it to you, like submit it.
Yeah, I think the my hope would be that we submit it through Canvas, and then Jaden, let me just straight say, you're not the only person. In fact, Jaden, I have been having a really hard time this quarter as well. Normally, I try to give my students written feedback on your work, graded written feedback on your work at least once a week. And I have failed at that miserably this quarter. And I try to forgive myself. This has been really hard for me. Do you feel that too?
Yeah, it's I mean this quarter, yeah. And I think I haven't done math until like since high school, since I graduated. And so like the first quarter I never did math, so I it is kind of hard a little bit virtually now. But I'll definitely try to get those done.
I've been working on it too. I've been trying to finish the solutions and I've been failing miserably. Like I get the first part done in class and then the solutions take me about 2 hours to finish.
Right.
So when I write solutions for you, because it takes about 2 hours to get through half the packet, right?
Mm-hmm.
And then when I go write solutions for the second half of the packet, that takes me about 2 hours. To create the packets themselves takes me between 3 to 4.5 hours. So just to make the packet itself, because I got to make the grids, I got to make the tables, I have to research the equations, I got to read the textbook to figure out where we're going next, I got to think about 48B. It just takes a lot of time to put those together. And then by the time I've spent the time building the things and then showing up to class, I'm literally, it's like time for me to go to my other classes, right?
Right.
And so the reason I tell you that story is that if I feel that way, I'm guessing that you feel that way too, right?
Right. And it's just like knowing that this is a quarter system. I don't have enough time to waste. Like, I mean, I don't have enough time in this system.
Yes.
And if I if I feel like, if I try to take my time on something, then, oh, well, this is already passed and like this happens. So like I'm trying to find a way to where I can work on it. And so like the tutoring, I'm trying to go to that a lot and get whatever help I need. And yeah, it goes by fast.
Too fast.
Yeah.
It's my least favorite part of the quarter system.
Right. But yeah, I'm just trying to get the help I need, and yeah.
Yeah, my goal is to help keep you all accountable.
Mm-hmm.
My goal is not to punish you, to make this punishing. And I don't know how to do that given the same struggle you just articulated, Jaden, I feel too.
Right.
I feel it because there's literally just not enough hours in the day, right?
Right. And to do other stuff, it's really hard. But it's just, yeah, it goes by fast. And
can we work as a team to figure out how to best do this together?
Do like the math and stuff.
Yeah, do the math and figure out, because I'm the same thing you just said, I'm struggling with too, and I would bet that you have some stuff to teach me, like, the ways that you might prefer, and the ideas about what would be helpful for you. I will learn from those, and then I can use that to help other students. And then hopefully the way that I thought about this, Jaden, was when we started this quarter, I have the intention that if you stay in this class, I want to get you an A. Just because this is other teachers, I think by this point, this is maybe their third time teaching virtually. And they might have ways that they can grade and teach at the same time. I don't have those right now. I haven't figured that out yet. And I also am teaching, so aside from teaching virtually, the fact that I'm teaching 48A for the first time is just, even if I was teaching in person, this would be a huge lift.
Right.
And years ago, so Jaden, they asked me to teach this class. Umoja program asked me to teach this class, the people that run the program, I think in like 2018.
Oh.
And so I had the way that, this is kind of an interesting story, and then we'll stop here, but I think this is useful for the story behind this. Have you ever seen my teaching history online?
No, I never looked at that.
Do you see this right here on our website? Do you see this little thing that says Jeff's course history?
Oh, I think I have. I didn't bother checking it yet.
Yeah, it doesn't matter. It's just you can see my entire history at Foothill.
Mm-hmm.
So they asked me to teach this class somewhere in this year. So it was like 2 years ago. And they wanted me to teach it last year, but it's funny because I'm working on projects right now that won't come to fruition until 2024, 2025. And so the reason I tell you that is that in my professional life, I'm usually like 4 years ahead of where I am in person. And so when they asked me to teach, I'm like, I can't do it next year. The earliest I could do it is in winter 2021, because you see these 2 professional development leaves?
Yeah.
Those are sabbaticals. So I'm basically at home. I don't have any teaching responsibilities. I'm just making videos. And at the time that they asked me, somewhere here, basically, I was planning to finish the spring 2020 thing. And then in the summer, I would finish all of my videos. And then I would take like 2.5 months in the fall and do nothing other than prep for the 48A class. So basically I wouldn't get paid I wouldn't get paid in the summer, but I would I'd finish everything that I was supposed to finish in fall. And that would have allowed me to do prep for 48A in the fall. And then when 48A started, I would be ready and I could do prep for 48B in the winter. So I had it all planned out so that the first day of the course, I would have been done with all the worksheets. I would have had made videos. I would have so much support would be in the class, but it ended up that because of COVID, my wife and I, we were in a small apartment. So in spring 2020, we were living in a small apartment in Redwood City, and it just wasn't feasible. And so it ended up that we bought a house over the summer and we moved. But that meant that all of the work that I would have done on this class, I didn't get done because I was in the process of going through the process of buying a house, packing my stuff, et cetera. And so I actually didn't start the project for fall until September. And then what that meant was I didn't get to start prepping for this course until the start of January. And so that's one of the reasons that this has been such a brutal thing, is because we are in the same boat, right? Like I am prepping the class and the same way you're taking the class together. And I feel really badly about that, because when I said yes to teach this class, my intention was that all of this was done before I ever met you. And I had done a lot of work to make sure to make that plan happen. And then a bat in China infected a person. And then here we are, right?
Yeah. Yeah, I just I don't get how it spread that fast. It's kind of weird to think about it, but I mean, I guess maybe it really affected like really fast.
Well, someday when you have that the word doctor in front of your name, you'll be able to tell me why it spread so fast, right?
Yeah, I know. Usually, like diseases from animals, they it's just like the poison sometimes, or like diseases that are hidden within animals. But yeah. Well, I'll definitely make sure I will work on all the worksheets and everything. And I was planning on, so what I would do is I'd listen to all the videos, right? And I'd work on the problems that you worked on the videos, like just write out those, and then whatever I have left from that, like the worksheet, like the rest of it, like what you assign us for homework, that's what I will want help on. And then I could probably finish that, and that's fine for me.
Yeah. So one idea that I have for you is, if I do this problem solving thing in the morning, I might have time after class, like between now and 1, which I think you've freed up. And then the other thing was, so we could actually do a little bit of problem solving together if you still have the gumption. We also have, let me take this offline real quick. Are you familiar with the STEM Center?
Yes.
You know PA?
PA, yeah.
One thing that we might do is, I think he works.
He does, yeah. He works.
Yeah, and if we got you, so like if you and I had one-on-one meetings, you and PA had one-on-one meetings, I don't know if Art is looking for extra work. I don't think you are, right, Art?
No, I don't think so. But I could
Yeah.
work after class a little bit occasionally.
Oh, you could do this little time frame after class?
I think so. Occasionally, but we'll see.
Yeah.
If there's something you want to do set up, like we would have to look at that. But
Yeah.
you need help every once in a while for sure.
Well, one thing that I think is useful is, would be nice if one of us was available for him to just work on problems. And usually students are trying to talk with me. But I will say, Jaden, one thing that you could do, are we gonna see you at the problem solving team meeting on Thursday?
Yeah, I'll be there at 8:45.
Awesome. Yep, you got it. Do you know how to get to this little like student support portal on Canvas?
Oh yeah.
Awesome. So right here, you know how to get to, I forget how to do this, how to get to the STEM Center?
For me, there's like a little box that says tutoring, but if you go
Tutoring,
down.
yeah, you got it. Okay. One thing that you might do is, if you go to STEM Center, right?
Right.
Like I would say 1 hour on 2 different days a week. and you could get this for free. So one question that you might bring with you to the to our meeting
Right.
is, if you look at the STEM Center tutoring schedule, and then I would go to the garden. Do you know what I'm talking about?
Yeah. The garden. Yeah. I actually taken it. I've taken it before.
Awesome. So like one thing that would be really cool is if you could give 2 hours a week, 1 hour on 2 separate days in the garden during sometime during these times. These tutors are pretty good. I don't know Judd. I've never worked with Judd, but I know Ellen well and I know PA well. And you could literally study in the garden, and then when you get stuck, you could ask for help.
Okay.
And so the question for you is when do you think the 2 hours that you could make work would happen?
Okay. Let's see. Anytime after 2.
Okay, so what if we were to say, do you want to do math on Tuesdays and Thursdays? Is that sound like a good deal for you?
I mean, yeah. Yeah. It's after. It's a good time because I could finish my math work, and during those days I don't have any other classes besides, well, Tuesday it's just 2 meetings and that's it, and the other meeting is not a class, but yeah.
Yeah, so what if we were to say that you commit to going to the garden on Tuesdays and Thursdays from like 2:30 until 2:30 to 4, right? And then like during that time, you try to finish as much of the rest of the worksheet as you can, basically.
Okay.
What do you think of that?
Yeah, that works.
So that means you have class, you got this little meeting right after class, you go to your next meeting, and then maybe take 30 minutes for yourself, and then 2:30 to the end of the you'd be working by yourself, but if you got stuck, you'd have people to help you.
Gotcha. Oh, for 30 minutes you said?
2:30 to 4, I was thinking, right?
Oh, okay, yeah.
I mean, obviously this is all your choice, but I mean that way you're not alone, right?
Right, yes. I would like that.
Awesome.
But yeah, that works. That works well.
Okay. And then just keep me posted on that, right? Keep me posted on how it's going and what you're thinking about.
Okay. All right, then I'll let you know how it goes. I'll probably later today I'll work with a tutor, either PA or Ellen. I think Ellen might be available. PA is usually Mondays and Thursdays. I'm not sure.
Yeah, it looks like PA's today and then Ellen's on Thursday, but although this changes though, right?
Right.
Yeah.
Gotcha. All right. Thank you, and I'll let you know how it goes.
Okay, great, Jaden.
Okay.
Good seeing you.
Yeah, nice seeing you too.